So the first approach that I'm going to show you is the most efficient, at least in my opinion. And then at the end of the video, I'll share with you how I actually first attempted it. And that would actually mean under exam conditions, I should have skipped this question because you only really get one good shot at a question. So here we'll start by dividing both sides by 2 to the power of 2x plus 30. And I mean, I don't know what the motivation for that is, but I guess the idea was to see if bringing this in the denominator and subtracting gives you something easier to deal with. I think that was my motivation. So we'll subtract those. So the exponents 4x squared minus 2x minus 30. And in the second one, and I can do this separately, the subtraction, because I'm doing division, minus 2x minus 30, which becomes 2x squared minus x minus 14 plus 1. And then you'll note here is that if I factor out a 2, I'll get 2x squared minus x minus 15. Because we're kind of expecting this term to be a square, some form of a quadratic. And here I can rewrite this, because I'm trying to connect these two. I have that piece here, and then I'll do a plus 1. And what that plus 1 means that this is same as 2 to the power of 1 times 2 to the power of 2x squared minus x minus 15. And then this really is 2 to the 2x squared minus x minus 15, this whole thing squared. So now that we're at this point, if I call this y, then I can rewrite this as y squared minus 2y plus 1 equal to 0. Well, this is a perfect square, which means y is equal to 1. So our entire equation has reduced to this, much easier to deal with this, equal to 1, which is 2 to the 0. So the solutions we're looking for is 2x squared minus x minus 15 equal to 0. This is the quadratic that will give us the two solutions. But note here, they're asking for the sum. So we don't even have to find the values, the solutions here. The sum here for a general quadratic is minus b over a, the sum of the roots. Here b is minus 1, a is 2. So the answer is half c. So this is, in my opinion, the most efficient way to do it. Now, obviously, my second attempt on this question was the fact that I knew 2 to the 1 plus 2 to the 1 is 2 square, because you can factor out a 2 to the 1 and you'll get 2 square. I also knew that if you did 2 cube plus 2 cube, then also you get it condensed to 2 to the 4. So I've seen these kind of additions, and this will apply to anything. 2 to the 10 plus 2 to the 10, you'll get 2 to the 11. Now, if the exponents are different, so for example, 2 to the 4 plus 2 to the 3, then it doesn't collapse to 2 to the power, meaning if you factor 2 cube, you will get 1 plus 2 or 3 times 2 to the cube. So how does this help me look at this question? Well, I said, let me put the plus terms on one side, and I move the other term. So now this is kind of becomes of this form, meaning it has to have this form where both the exponents are the same. So that was kind of the insight, but I knew these additions already. I also knew that if they were different powers, you will always get some other number, meaning if it was 2 to the 5 plus 2 to the 7, it would be 5 times 2 to the 5. It won't collapse to 2 to the power. So that meant that the condition is 4x squared is equal to 2x plus 30. And you will note that this is the same as the quadratic earlier. Now, when I actually did this and the exam conditions, I wasn't really comfortable with just kind of making a conclusion from this that that's it, because I was worried, does it even work out? So I actually ended up solving this quadratic. Now, of course, you probably won't have the luxury to do this in exam, but let me just kind of show you what happens and why I would actually still choose to do that in the exam. So I do want to caution here that this is extra work. but if I want to be absolutely certain, so x was 3. So then I said, let me just plug that in and see, does this work out? 9, so 2 to the 36, 2 to the 36. And if I plug in 3, so that's 18, plus 3, 21, plus 16. So that's 2 to the 37, which is indeed true, because if you factor out 2 to the 36, it becomes 1 plus 1, which is indeed 2 to the... So that one worked out. And if you do that with minus 5 over 2, again, a little bit more work, it also worked out. So because I took this a slightly unconventional approach, I had to kind of do this extra work. Of course, if I were really just running out of time, I would just take a chance and say, you know, this piece I don't have to worry about whether it works out or not. And I would just, of course, find the sum just as I did earlier, that the two solutions add up to half. Now, how did I originally approach this question? Because that's also a general kind of a method for these types of questions, but this was different. What I tried to do was to rewrite this as 2x squared, and then I said, okay, I have a 2x squared here. Actually, no, I wrote this as 2x squared times 2. And then I split this out, 2 to the 16, and then 2 to the x, 2x, and 2 to the 30. And I was thinking at this stage, I'd be able to factor something out and maybe a simpler quadratic inside to deal with. I wasn't able to do that, meaning I just got stuck in this loop. And of course, you only have one shot in the exam, and that's what I meant, that because I headed in this direction, which is a common thing for this type of a question, and it was the incorrect method here, I would have just skipped this question in the exam. So that's kind of the lesson, that you have to be flexible. Maybe under some other circumstances, I would have abandoned this earlier and gone with either of these two approaches. And that's exactly what you're trying to train yourself when it comes to problem solving, and not stick to any particular method. Of course, you have to try what you're familiar with, but be open to it. So to summarize this question, which is a difficult one, is choice C.